you're fretting, what is the u? So this is pretty much the same as that. So I hope that makes it clearer what the u is now. So the u is this one, and you can see the derivative is present. So it's just kind of a trick to this one. It makes you think, oh, maybe t is the u or something. So there you go. So cos t. Okay, so some of you got that, well done. And then we have the derivative of cos. So negative sine t. Okay, then we rearrange to get t by itself. All right, so that's step 1, 2, and 3. Remember what we did before. Then we're going to substitute in this, and we're going to substitute in this into this function. So we leave sine t. We've got cos t cubed, so we're going to sub that in. It becomes u cubed, and we're going to change dt for this stuff here. So make sure you're copying this down in your books, guys. Alright, so now you can see the derivative is going to cancel out. So we're left with negative u cubed du. And we've done this quite a few times now, this integral. So we add to the power, divide by the new power to integrate. And then we substitute back in what the u is equal to. That's why it's called integration by substitution. And that's it. So same 6 steps as last time. And don't forget the plus c. This is called when the derivative is present. So hopefully you guys remember the derivative of ln constant times x. The derivative of this is 1 over x. Hopefully you remember that from methods. So you guys guessed correctly. We're going to let this equal to this, because when we differentiate that, we're left with this one. So we know this is going to cancel out to that x on the bottom. As you may remember, so we've got x du, and then we're going to sub in this and this one back into the equation. So that becomes, so that's subbed in, and this one's subbed in. We're left with that. And now you can see the x's are going to cancel out. So we're left with this one. And then we always sub back in our original function for the u. So we have ln 3x squared plus c. But that's okay. So we've got this dash symbol, which is the same. So this is the derivative of f of x. So to find f of x, we need to find the integral of the derivative. Alright, I'm going to tell you. It's x squared. Oh, who would have thought? Very interesting. So you can see when I differentiate that, it's 2x, and you can see the derivative is present. Ah, surprise, surprise. There you go. So you rearrange to get dx by itself. We then substitute those in. X's cancel out. Anyone remember? It's on my many math posters. This is the same thing. And my bad Pokemon poster, same thing. There you go. Alright, and then we substitute in the u function. Yes. Alright, and now this one, it has an extra step. When the function is 0, it's equal to 5. Oh, interesting. So this helps us find the c value. There you go. So if all of this, e to the 0 plus c, e to the 0, what's that? Very good. So this equals 1. So we bring it over to the other side. Comes minus 1. So c is equal to 4. Therefore, the function equals e to the x squared plus 4. There you go. Very nice. Well, I hope that was useful, guys.